We will read carboxylic acid today. This is another homologous series. The functional group of this acid is this COOH, and you look at the diagram. Look at this functional group diagram. The functional group of carboxylic acid, and this is the structure or displayed formula, displayed structure of carboxylic acid. Each and every carboxylic acid must contain this structure. The first member is methanoic acid. Ethanoic acid is the second member, which we know generally as vinegar. Vinegar is an aqueous solution containing ethanoic acid mainly. Carboxylic acids mainly formed by the oxidation of alcohols. For example, ethanoic acid is formed when ethanol is left in the air or oxidized using potassium dichromate 6 in dilute sulfuric acid. This one we already read in previous chapter. Now look at this table. There are some common carboxylic acids are listed here with their name, their molecular formula, their structural formula, and their displayed formula. First member is methanoic acid. You look at this HCOOH and look at the displayed formula structure. Ethanoic acid, it's CH3COOH. If you know the structural formula, you can write molecular formula, it's easy. So CH3COOH, look at the displayed formula. Propanoic acid, CH3CH2COOH, and look at the displayed formula of propanoic acid, 3 carbons, and butanoic acid, CH3CH2CH2COOH is the general formula of butanoic acid. Now look at this. Let me shade the functional group. This is the functional group in methanoic acid, the functional group, common functional group in ethanoic acid, the common functional group in propanoic acid, and the common functional group in butanoic acid. So this is, see, this is structure. It is present everywhere in each and every member in carboxylic acid. So here H, just adding an H, it forms methanoic acid, CH3, it is ethanoic acid, CH3CH2, it is propanoic acid, CH3CH2CH2, it is butanoic acid. All right. Now, acidic properties of carboxylic acid. We will read that carboxylic acid is kind of acid, so it has definitely acidic properties. And it is actually weak acid, and its pH level is from 3 to 5, as these are weak acids. Still, they carry the properties of acids. They will turn blue litmus paper, damp blue litmus paper red, or blue litmus paper red. They react with metals to form metal salt plus hydrogen. They react with metal carbonates to form metal salt plus carbon dioxide plus water. They react with alkali to form salt and water. First of all, there is an example here. Then ethanoic acid, it is reacting with magnesium. Look at this reaction. It's reaction between ethanoic acid and magnesium. Magnesium reacts with ethanoic acid, it forms magnesium ethanoate and hydrogen. Dilute ethanoic acid reacts with magnesium with a lot of fizzing. So it's a general properties of acid, produce a salt and hydrogen. The salt formed is magnesium ethanoate. Look at this structure, magnesium ethanoate, which is soluble in water. It's an ionic compound and is soluble in water, and so you get a colorless solution. We get a colorless solution. Magnesium ethanoate. Here there are 2 ions. One is magnesium ion and one is ethanoate ion. Ethanoate ion is CH3COO minus. That is ethanoate ion, and this is the style to write magnesium ethanoate. Ethanoate ion first, magnesium later on. Remember this. Look at this. This is the ethanoate ion structure. This is ethanoate ion. So similar reaction with zinc, it would form zinc ethanoate and hydrogen. Should be right. When ethanoic acid zinc produces zinc ethanoate and hydrogen. Zinc ethanoate solution, that is colorless solution of zinc ethanoate, and hydrogen gas, bubbles of hydrogen gas seen. Colorless solution of zinc ethanoate and bubbles of gas seen. This is observation. Now the reaction is zinc plus ethanoic acid CH3 COOH arrow zinc ethanoate. So CH3 first, C, then zinc, 2 here, 2 of zinc, H2. Now let's balance it. So put a 2 here. It's balanced. This is zinc ethanoate and hydrogen. All right. And metals below hydrogen in the reactivity series would not react with this acid, such as copper, metals below hydrogen in reactivity series, such as copper, not react with. Remember this. So even if I give you the question that write down the reaction between copper and ethanoic acid, you have to write there would be no reaction because copper is less reactive than hydrogen. Now look at this. That is two other reactions. Carbonates react with acids to give salt, carbon dioxide, and water that we know. And here is the example that ethanoic acid is reacting with sodium carbonate. So it forms sodium ethanoate plus carbon dioxide plus water. Sodium ethanoate, it would form colorless solution of sodium ethanoate, aqueous. Look at the state symbols, aqueous. Carbon dioxide gas, it would form bubbles of gas or fizzing, observed. And ethanoic acid reacts with calcium carbonate. Look at this. It would be calcium ethanoate, carbon dioxide, and water. Similar reaction we can write that ethanoic acid would react with magnesium carbonate. Doesn't matter. It would form magnesium ethanoate, carbon dioxide, and water. I can show you this. Look at this. This reaction is for magnesium carbonate. So done. This magnesium carbonate. Look at this. It's magnesium carbonate reacts with ethanoic acid to form magnesium ethanoate plus carbon dioxide plus water. All right. Similarly, as sodium carbonate is reacting, we can even change here potassium carbonate. You want to see? Instead of sodium, I want to change by potassium. So it's done. I want to make it color shade so that we can understand. Look at this. Potassium carbonate reacts with ethanoic acid. It forms potassium ethanoate plus carbon dioxide and water. Now the thing is that what would be the structure of potassium ethanoate? How would it look like? This is the ethanoate structure. Just you add the potassium ion here with oxygen, and it would be potassium ethanoate. Let us draw. Double bond, single bond O, double bond O, CH3 here, and just put the potassium here. And see, this is potassium ethanoate. All right. This is potassium ethanoate. Okay, similarly, we can draw sodium ethanoate. Just instead of K, we can put Na. It would be sodium ethanoate. But what would be magnesium ethanoate? Look at this. What would be if it is magnesium ethanoate? There would be two ethanoate ions. There would be two ethanoate ions. So let us draw it. CH3 C O. This is the one ethanoate ion. Then magnesium. Then again another ethanoate ion. So O, carbon, oxygen, CH3. Look at this. There are two ethanoate ions. So this is the structure of magnesium ethanoate, this one. It's a bit bigger, right? But easy. In both sides, there are two ethanoate ions. If you underline, this is one ethanoate ion. And is another ethanoate ion. In between, there is a magnesium. So there is two ethanoate ions. Look at this. There is a 2 here. This 2 indicates that there are two ethanoate ions because you know the charge of magnesium ion is Mg2 plus. So if it is aluminum ethanoate, Just think about that. How many ethanite ions will be there, as aluminum has charge of +3. And to definitely, we are not going to draw aluminum ethanoate. We don't have sufficient space here, and it is not even necessary. Here there are some question answers given. So draw the structural formula for the following compounds: ethanoic acid, butanoic acid. You can draw it. It is even given in the table listed in this chapter. Draw the displaced formula. So this is structural formula. This is displaced formula. Ethanoic acid CH3. CH2, COOH. And butanoic acid, there will be 4 carbons. So CH3, CH2, CH2, COOH. And the display formula. Name the following compounds: 1, 2, 3, 4. This is butanoic acid. Sorry, it's capital letter. Butanoic acid. And this one is ethanoic acid. Okay. What are the functional groups shown in the compound below? What kind of functional groups? What are the different functional groups? Let us mark. Where is my highlighter? What is COOH here? Look at this. COOH, this one, and COOH, this one. So this is carboxylic acid functional group. One is carboxylic acid. Another one is carbon-carbon double bond. You can see this carbon-carbon double bond. So this is the functional group of alkene. Alkene. So we identified 2 functional groups. One is alkene and another one is carboxylic acid. And there are some simple questions given here. Look at the reactions. You can solve them by yourself easily, no problem. This is heat under reflux apparatus. Propan 1 all, it would be propanoic acid. Then after oxidation, the color change, it would be from orange to green. Magnesium vapor and sodium carbonate solution, they react with propanoic acid. So magnesium propanoate, it would form magnesium propanoate, and sodium carbonate from sodium propanoate plus carbon dioxide plus water. Now what would be the structure of propanoate ion that we can solve? Look at this. This is the structure of ethanoate ion, just CH3 here, and we will write CH3, CH2 to make it propanoate ion. All right, this is propanoate ion, 3 carbons. Now this question, look at this question number 4. Vinegar can react with baking soda, which contains sodium hydrogen carbonate, to give a salt, carbon dioxide, and water. So vinegar is ethanoic acid. Is vinegar to write? We will write ethanoic acid. Sodium ethanoate plus carbon dioxide plus water. What kind of reaction is this? It's a neutralization reaction, definitely. So just an observation, as carbon dioxide gas is produced, so bubbles of gas seen, we can write. A very simple thing. Right? So you read these things. I hope that it's a very easy chapter and you can understand everything.